So welcome everyone. As I was already introduced, I don't think there's a need to introduce me again. I've been with Mews for 6 months now, and I'm already being forced to wear their merch. So this is voluntarily, of course, but I'm always happy to do that. And today I'm going to talk about our infrastructure SDK. And I just want to say that the title might be a bit inflated because done right is exaggeration to some degree. But I think the most important part is our journey with Pulumi. And actually, I found one quote, and that is, we do not do it because it's easy. We did it because we thought it would be easy. And that's applicable to most DevOps solutions and tools, I would say, nowadays. So I just want to start with some preface and the topic itself. I think most of you use Terraform or infrastructure as code one way or the other, be it on-premise or in the cloud. And to some degree, like in the old days, the infrastructure was quite scattered and all over the place, I would say. It was mostly about config management tools, some infrastructure as code tools like Chef, Puppet, or Ansible, which were actually used to manage like infrastructure and resources mostly on-premise, and on the cloud it was mostly about VMs, right? So there wasn't that much space for developers to actually go in and start declaring something themselves, which it wasn't simple, but it was working. And the issue was that it kind of widened the rift between developers and operations. And like the operations were those guys that actually got the code and were told to make it run somehow, somewhere, and do something with it, which, I mean, it worked, but it was frustrating, and it still is. So you probably know the feeling. And also, a lot of these early tools were actually procedural and imperative. So every single one of them usually had their own language, their own some sort of syntax, conventions, patterns, ways how to do things. And ops people usually spend most of their time trying to play catch up with those tools, how it works, and what needs to be done to actually declare the infrastructure, which obviously gets tiring after a while, and it wasn't going anywhere. So, or there was actually one thing, YAML. Like if you ever had to declare anything in YAML, then you probably know that it's frustrating to a degree, and it's not a way to go. In 2014, actually, there was one contender to challenge the status quo, and that was Terraform, which actually was sort of cloud native. I kind of hated buzzword, but still. And it worked with multiple providers. It introduced new language, HashiCorp language, which was easy, declarative, and there was this untold promise that it would actually close that gap, and you could easily tell developers to learn a new language, learn HCL, be done with it, and you can continue like this for years to come, which admittedly sounded too good to be true, and it was too good to be true, because as adoption grew and got easier, so did the management. But it was mostly about the ops team or DevOps team running things like Terraform in pipelines or using Terraform Cloud. Like the adoption grew and management got easier, but at the same time, it didn't quite solve the one persistent problem, and that was how to do DevOps properly and how to offload some of their ownership back to developers and create a platform and not infrastructure per se. And then there was a new rival, Pulumi, which over the years, as the industry shifted, there was a need for something more developer-centric. And especially as the complexity of infrastructure grew, you had microservices, you had new programming paradigms, and it wasn't quite sustainable because you probably know it, I know it, that managing hundreds or thousands of Terraform resources for all developers, hundreds of engineers, is not quite suitable. You can create modules, you can create some abstractions, let's say, you can run it in pipelines, you can create some developer platforms, but unless they actually learn the language and know how to provision it themselves, then there's still gonna be that age-old discrepancy and nothing you can do about it. Pulumi actually took the best concept of Terraform and came with a bank, which was multi-language ability. Write something in an imperative general purpose language, and it's gonna get converted to the provider schema, and it's gonna, apply and provision some resources, which finally now ops and developers can find sort of an intersection between how they do things, which language they write, and at the same time, Pulumi and the conventions are very similar to how normal product code is actually written, to a degree, of course. It's more declarative, it can be different, but it's still the same language. And if you have some internal conventions, some patterns, or just the way you do things, then you can apply it to the same principle and you can apply it to the infrastructure. So no more HCL, no more DSLs or proprietary languages, and ops and dev are going to speak the same language basically, which was the goal. And also Terraform knowledge was transferable because in the past, I don't know what's the situation now, Pulumi actually used the provider schema quite similar to Terraform or the same to Terraform. So the state management, the remote state first, the backend management was still the same, and the knowledge of actually operating the tool is roughly the same. So Pulumi nowadays actually offers very similar features like Pulumi Cloud, environments, secrets, configurations that you can declare right in the Pulumi Cloud and then reuse across your stacks. And at the same time, you have things like policy as codes or packages as modules, which is a new thing. And all of these things that were lagging behind in the last couple of years are actually sort of revived and brought to the game, which is quite challenging for Terraform, I would say, especially these days when HashiCorp introduced licensing change from MPL v2 to BSL v1, which basically means that if the underlying code uses Terraform, then you can use it in your own product. So that quite hampered the open source tools. And I don't know if you've heard about OpenTofu, but it's a fork of Terraform and they're doing quite amazing things. But HashiCorp actually sent them a cease or desist letter, which forces them to, they can fight back, of course, but it's legal battles. So corporations are usually risk averse. So if somebody told you that this tool might get shut down or that it's open source, then you probably wouldn't want to, migrate to that tool anytime soon. So that's where I think Pulumi has the biggest strength right now. And also the rise of platform engineering is speeding up this process, like internal developer platforms, treating infrastructure the same as your product, including versioning, release management, and of course the code itself. And this is mostly how it looks like. That's the desired state, that's the actual state. I think you will understand. So Pulumi at Mews, how our journey started, what was the point, and what are we gonna do next? Actually, we started experimenting with Pulumi a couple of years ago, and it was mostly for the fact that the number of Azure resources grew sort of exponentially, and ClickOps just doesn't scale and doesn't work in the long run. So we needed an infrastructure as code tool, but at the same time, the original team or people interested in infrastructure were developers first. So they actually wanted to write infrastructure in a language they know and sort of bend it to what they needed at that moment. So that's actually one of the reasons that we needed to also accommodate for our new Atlas framework, which I'm not gonna go too much into the details, but it's not a microservice architecture per se, but it's a service-oriented framework. And that also means that the Atlas adopters can basically deploy services outside of monolith and the infrastructure is in their own ownership as well. So that's something we needed to take into account. There's not going to be one ops team that will manage, let's say, a huge Terraform monorepo and just add resources as needed, because that wouldn't be sustainable in the long run. So that's actually why we started treating infrastructure as internal product. And that comes with some sort of abstractions. And also, we wanted to combine the best of both worlds, declarative and imperative approach, when we can write the infrastructure imperatively, but at the same time, for those developers that use it to provision resources, it's mostly declarative. So that's why we created our own internal infrastructure SDK, which is quite a fancy name, but it's just a library that anyone can use. And it's an abstraction over Pulumi classes, Pulumi types, and overall what Pulumi has to offer. And basically, instead of letting devs handle the complexity, we abstract most of it by taking care of permissions, let's say assigning managed identities, and also basically preparing naming conventions, stuff like that. So they don't have to think about that, and we don't have to be too worried about security or some, let's say, code conventions. So why did we choose Pulumi over Terraform? As I mentioned, it was predominantly C# development, so we had much more freedom in how we do things and why we do them. Devs started taking care of infrastructure, so we had initially basically the platform team split off the backend developers, so they wanted to use the same language they're used to, and also ease of use and being able to actually version properly, handle some releases, and introduce new features gradually without actually going all in or going too fast iteratively. We also started using Pulumi Cloud, which was quite a no-brainer, because of course you can manage the state yourself. You can create some S3 bucket or blob storage and just deploy there, of course. But the thing is that we wanted a seamless management, and why not throw some more money at it if we don't have to manage it? Which, of course, we are revisiting that decision quite periodically these days, but I mean, initially this was the way to go. And also very straightforward onboarding, either of new team members or developers, new people, and also new stacks mostly, because we split our infrastructure in a lot of different stacks, like monolith stack, networking stack. So we have more control, let's say, and insight into what we actually do. And in that case, Pulumi Cloud is really irreplaceable, because it's easier to see when was the last deployment, was it successful, what were the changes, and I think that's a big one. So put a holidays infrastructure SDK, why would anyone do it? And the saying, don't write your own database, and if you can, don't write your own abstractions. Well, we did it, but it was mostly easier to implement and abstract golden paths and sort of bake in best practices, security policies, as I mentioned, code conventions, and at the same time, create this sort of shared responsibility model when we will take care of these, let's say, harder infrastructure things, like chaining them together, like creating the resource, creating role assignment, and stuff like that. And at the same time, those who actually provision those resources can do so without our intervention, let's say. Also, everything is baked in using regular imperative approach. That's why it's quite a complex code base, and admittedly, it might be hard to contribute actively to it at some point, especially if you're new. But from the point of view of the adopters, it's really easy. And you're gonna see for yourself that if you were a developer, for example, at Mews, you came into the company and someone told you that, this code needs service bus, then, you're just gonna look into the documentation, see how to do it, see how to declare it, just import the library into your project, and in 5, 6 lines you're done, which I think is really a technical feat and achievement, but it has its caveats. So I think the most important question, do you regret it? And we'll get to that later. So this is how it looks like. I'm just gonna find the, yeah. So basically you have these stacks, and then you have different environments, and you can see when they were updated, how many resources you manage. You can see the active state, which I'm not gonna show because that's internal information. And it's a breeze. Look at this. You can see the changes, the providers use as well, and of course the diagnostic. So it's really easy to actually do stuff, and you don't need to be using your command line or trying to read something from the state file directly, which admittedly happened a lot to me when I was using Terraform and I needed to read something from the state. Then it could be a bit painful sometimes, especially if you had hundreds or even thousands of resources in the same state. So we started slowly moving away from monolith, as I mentioned, and then we started offering something called building blocks, which is exactly what I mentioned regarding the infrastructure SDK. It's giving developers something to work with, something to start, and it can be related to caching, service bus, alerting. Basically, it's an abstraction that they can use and sort of supplement with their own values, and it's going to be provisioned for them. So there's one pattern, there's one way how to do stuff, and each adopter uses the same approach. So there's no risk of running astray when it comes to your code bases, no risk of actually realizing in a few years that two of your services look completely different and you don't know why. So it's actually about easing the adoption and also help to establish some sort of common way how to do stuff. And also, it's about sort of ownership and how we actually separate these monolith resources and Atlas resources, be it with the building blocks or be it with the infrastructure SDK. It's all about like giving them some platform to use rather than helping them create it per se, which scales much better than if you had to do everything from scratch every single time you have a new request. And yeah, just to give a glimpse into our stacks and how many we actually use, this is what it looks like. And we have one monorepo that acts sort of as a gateway to our infrastructure. We do manage monolith internally, which means that we take care of monolith resources. We declare some common classes and methods for common resources that we use and declare quite often to just make it easier and more maintainable. But this is something that's not visible to the adopters and to other people, basically outside of the platform engineering team. And then, of course, the repository also contains the entire SDK, which we're going to get to soon. And it's going to be a massive difference. You will see for yourself. And yeah, so it's ready to specify things like naming, multi-region deployments, environment configurations, you name it. Basically, a lot of these nitty-gritty details that you need to think about when you're actually provisioning something via infrastructure as code, we do magically under the hood and behind the curtain, and they just need to declare the resource. Also, due to having everything in one place, we can easily split CI/CD in our GitHub Actions based on a path. So for example, if somebody contributes to any of these stacks, then we can deploy them directly by Pulumi app, Pulumi preview, which we also run Pulumi preview on all new PRs. Or if it's something in SDK, it's gonna be published as a NuGet package. which also means that's something that is quite important. Choose your CI/CD tools wisely, because right now we have 3 different tools, or rather 2 different tools for infrastructure, and it can get a bit messy sometimes, and especially as the number of stacks grow as well. So consolidate early and pick 1, 2 maximum, but try to stick to 1. And probably the highlight, this is how it looks like in a monolith stack. For example, this creates a resource group, pretty easy. I don't know if you know C#, but this is pretty self-explanatory. And this is how you use it. And this is the infrastructure SDK. And it creates a key vault. And you have these things like, for example, handling exceptions. You have app identity access policy, key vault access policy, and this is the naming convention, as well as some other things like location deployment, region deployment, and things like tags, protection from deletion. These are just some additional things. And this is how it's actually defined. You just say add key vault, specify location, add name, and eventually optionally access policies. And that's it. So as you can see, it's much easier for the adopter. It's way easier for them than it is for us. And it works like this with most of the other resources. So you can, I think, clearly see the difference. And how do we actually publish the NuGet packages? So as I mentioned, we use GitHub Actions. You can see it here, pretty easy. And we push them to Azure DevOps registry. Later on, they are actually referenced by our Atlas adopters. And it's up to them. Like if they request a new feature that we implement, they can just simply bump the version and start using it right away. Which I'm not saying we use them as guinea pigs, just sometimes. And now the fun part. What's the good thing about it? What sucks? And what's absolutely horrendous? So the good thing is pretty easy. It's much easier adoption, shared responsibility model, which I already explained. They don't have to care about security, blogging, stuff like that. Also, we are more aligned. We help them with sort of design choices. We know what they're working on, so we can sort of add new features and support them accordingly. And also there's some structured approach to building the platform, which means that we treat it as our own internal product and we treat them as customers rather than being a support that's usually there just for the requests and the ad hoc stuff. For example, I don't know, give me this permission or create this topic. They can do it all themselves, and we are just simply providing the means. Of course, the iteration is much harder and the testing is, well, I'm not saying non-existent, but really hard compared to DSL. It's very easy to write spaghetti code, drift from best practices, and basically do all these nasty, ugly stuff that just don't work. It's also proprietary, so like we are, I think, the only company who actually uses the SDK and who does this, like create abstraction over already abstracted infrastructure as code tool. So we can just look at some blog posts or conferences or tech talks and say, oh yeah, this company is doing this and that, maybe we should follow their path. We need to rely on our experience, our sort of knowledge in how we do stuff. And it's a good and bad thing. I mean, on the one hand, we're constantly learning. On the other, we might be straying away from what's actually going on in the industry, but it's like that with everything. And it's also hard to document all edge cases because, again, this is general purpose language. So like with DSL, you know the limits, you know what can get wrong, you know that you can fuck up at something specific, but with a GPL, it's really hard to know exactly the ins and outs and how it's gonna behave live or in the real world. And the ugly, it's really, really difficult to onboard new people. Like when we are hiring, we need a combination of infrastructure skills, of course, soft skills to some degree, and mostly programming skills, because again, most of what we do is in C#, and it's really hard for people, let's say, accustomed to Terraform, to come and start contributing to the SDK or even to our internal infrastructure. So there was massive growth in complexity. The code base is huge and it's growing every single day. It's also quite opinionated, I would say, which is not a bad thing. I mean, we stick to some conventions, but like if you wanna iterate fast and test some things and really like move fast and sort of break things, then it's almost impossible because it's somewhat fragile. And if you introduce some new bug, it might not get detected immediately, or it might break the backwards compatibility, you name it. And there's also the growing tech debt, because we have some duplicate methods, duplicate classes. We have some resources, for example, that are not up to par regarding the features, but we are working on it. So as Michael Scott once said, you miss 100% of the shots you don't take. And I think that's about it. I mean, overall, our approach is very different. It's unconventional, it's hard. And sometimes it's a bit annoying, both for us and the adopters. But I think what we do is sort of a technical feat that not many companies would be able to risk. And we're getting better at it. Now that Microsoft released Aspire, we're free to experiment with some new stuff. And yeah, I mean, do we regret it? Probably not. There's still a huge room for improvement, but on the other hand, it's fun. And we are writing code, not YAML, not HCL, so we're happy. Okay, thank you.
Okay, what about integration testing, for example? When you make modification to one of your bundlings, do you test it that way, or?
Well, I mean, we don't like do integration testing per se, because like the way it's structured, we're still using like the underlying Pulumi classes. So basically you see if it's gonna pass or not, but usually we test it like in separate repositories where we like try to create a resource per se or implement that new feature and then see how it actually behaves. Because the thing is, Pulumi is like, there's not that much of room for actual, let's say, unit testing. I mean, it's doable, but it's hard, and it's not that suitable for, let's say, how it would behave in a real world. Because what Pulumi does is that it runs the code just simply to provision the resources and to communicate to the APIs, but it's not long running and it's not something that you can test easily.
So there's no, I saw the code when you had, for example, args to the key vault, something you can, for example, check what the result is of the creation of a resource, what it would be like, or?
We could potentially like fill it with mock data and see what it, like, if it creates something. But again, this is usually tested on separate repositories where we like bump the version, check the new package, and then we use the new feature or the new resource. I mean, good point. It's not that suitable, and there's some manual effort in that. But on the other hand, like with this, it's really hard to catch everything, and especially when you have a lot of optional arguments, and even like things like, for example, multi-region deployment, then there are some intricacies, let's say, that might be related to the cloud provider or some specific timeouts. You know, it might take longer than expected. So it's not that deterministic in some ways than if you were, you know, writing your own code, sort of.
Maybe just one thing to that is that, like in every service repository that we have, Anytime you do any sort of changes into this infrastructure as code, you actually see the results on the PR. So every PR that is created gets automatically previewed, like what the changes will do.
Yes.
So you have like some form of verification that you are not doing some destructive changes that you will not be aware of.
So you can see the basic stuff, like as Richard mentioned, you can see on the Pulumi preview if it's gonna pass, but it doesn't mean that it catches all unhandled exceptions or it catches, all edge cases, but it sort of prevents the usual, I don't know, typos, issues like that.
You talked about optimizing for golden paths. Can you talk a little bit about the sad paths and edge cases that you get to look forward to?
Excuse me?
Can you talk a little bit about sad paths or edge cases that we should take care to not fall into if we were to transition to Pulumi or
I think edge cases would be definitely trying to ease down on the complexity and try to keep it simple, because I think that the initial idea behind it was really good, and it was to create a simple abstraction with some conventions, as you saw, but it sort of grew uncontrollably into this beast of a code base where it's really hard to actually find how that individual parts actually chain to each other and how they interact. Because, for example, if you have 4 or 5 different methods that create the same resource, and then you have some abstractions, around them, then it's really hard. So, like, I would say, keep it simple, stick to some really well-defined use cases, and think about what you actually want to do, like how many, for example, adopters you're going to have, what features you need, and then do it deliberately rather than ad hoc, or rather than basically just contributing without thinking where it's going to lead or if it's not unnecessary.
I have read yesterday an article comparing Terraform with Pulumi. It was from a company called Gruntworks, and they say that to compare both products, one has to pay also for this paid option for Pulumi service in order to get the best of it, and only then it's possible to compare Terraform with the Pulumi service and Pulumi. Do you share this?
I don't think so. I think that by default, like as an open source tool, Pulumi and Terraform actually offer the same. Like you can manage the state yourself. In the end, it's just a tool. But I mean, of course, if you go for Terraform Cloud, and admittedly, I'm not that familiar with Terraform Cloud, but from what I saw, it offers roughly the same features as Pulumi. Like you have some secrets management, you have some managed state, and you can also easily, for example, reference other stacks or other state files, stuff like that. So, I mean, I quite think that if you want to compare those paid products, it might be roughly the same, and so goes for the open source. Like, I'm not aware of some big thing that was, really be in favor of Terraform or in Pulumi.
Thank you.
So can you expand on that? So in the article, it was mentioned that to compare Terraform with Pulumi, you have to pay for the Pulumi cloud, but you don't have to pay for the Terraform cloud. It was on ThoughtWorks?
Huh?
It was on ThoughtWorks?
It was on Gruntworks, I think.
Grunt.
All right, do we have any other questions? Okay.
Yeah, maybe. Right, you said you got all the stacks and all the SDK in one repo. Do you have also monolithic state? Do you have separate states for the stacks?
Actually, how it works with the state is that in Pulumi it's called stacks, and each stack has some defined resources, like a Terraform state file. And so we have, like, for example, one monolith stack, but we have different stacks for networking, for Kafka, for example, for some specific, let's say, resources that don't belong to any conventional environments. And we usually try to keep it, like don't create too many stacks, but it's based on the function. So it's like if it's the same environment, we can also split it into projects, which is like a sort of substack, or how to say that. And yeah, but when it comes to monolith, we do have per environment stack basically, or rather per environment resources.
Right, and when you have a deployment, I would assume that a deployment would be more of a rather application-like or maybe business-like. So you deploy, let's say, this stack, but it crosses all the networking and maybe application deployment. It's just
yeah.
a single deployment that goes across multiple.
I get what you mean. The benefit is that basically we do this via GitHub Actions. So that means that we have some defined paths. For example, if you contribute to a networking stack and to, for example, monolith, because you're creating a new resource in a different subnet, then it's both gonna get deployed at the same time. The difference is, I didn't want to get into too much details, but for each stack, we simply run Pulumi preview and Pulumi app directly in GitHub Actions. But for the monolith, we actually create a release in Octopus deploy. So there's like a life cycle from develop to production, and it's easier for us to see with manual approvals. For example, if we go from develop to demo and from demo to production, there's some manual approval that actually runs preview again, so you can double check it and then decide if you want to proceed. I mean, both are running Pulumi up in the end, but it's just the way that we handle the life cycle.
And how do you handle race conditions in this case?
Race conditions, we usually use depends on or some parent resources, which means that it admittedly used to happen a lot, but we're finally teaching ourselves how to use sort of parent and child-like resources, some chaining them together. So for example, if you want to create a role assignment for Redis, then it depends on Redis, and Redis needs to be created first.
Well, I was thinking of race conditions between different deployments. Let's say two people want to deploy, basically in the same state file. And you have to go, if you go through Git, maybe you have to go through rebasing, and then you've got conflicts and new changes that, and you always have to basically do both of the parallel deployments, let's say, are deploying against the same state file. So one of them will come first and possibly destroy the changes that the other made.
This can happen, but at the same time, like usually, on each commit, you have the preview of your changes. So for example, if you're touching a resource that somebody before you deleted, then you're gonna see it in a preview and you can adjust. But this doesn't happen often because I think that, the number of resources that we manage or the different stacks, like it would be quite hard to do this. It happened in the SDK, like for example, when we were sort of touching the same parts of code when working on new features, but when it comes to monolith, then it's not that much of an issue.